Good morning, guys. This is the fourth video. So, in this fourth video, I'm going to explain the design of welded joints by myself or Harry Samuel. So, in the mechanical engineering design, we're having 5 units. The previous videos I explained about the fundamentals of mechanical engineering design, and apart from this, then failure stage, everything we discussed clearly in the previous video. So, it's a small topic. Design of riveted joints and welded joints is unit comes under unit 3 in the mechanical engineering design. So in the welded joints is nowadays is a very most recent topic, because every application, every marine application or every sea application, offshore, onshore application belongs to the design of welded joints only. In the design of welded joints is two category by normal joints and the eccentric loaded joints. Only two categories are there. So I am going to explain the design of welded joints in the concept of 18 MEC 280 mechanical engineering design. First of all, it is a permanent joint. Why it is called as a permanent joint is nothing but normally riveted joint is a temporary joint. Why they called as temporary joint means whenever we need to dismantle the component, we easily dismantle in the case of riveted joints. But in the welded joints, when you are welding two components or two plates or any two objects, we cannot dismantle after some time or some position of time. So this is called this is the difference between temporary joints and the permanent joints. So in the permanent joints, so it's a welded joint is a permanent joint. It is obtained by the fusion of the edges of the two parts to be joined together with or without the application of the pressure and the filler material. So here one word, one new term called filler material. Filler material, what is the purpose of filler material is when you're going for the working operation, the high temperature, the filler material released some material in the melting point of material is melted, and it is joined with the base material. Base material is nothing but the two plates which are going to be joined is the base metal. So base metal also reacted with the melting point, and filler material also can react to the after the melting point. So two metals join, and the whole welding operation is over. So compulsorily we need the help of the filler material. Without filler material, we can't go into the welding operation. In the recent welding operation, that is a solid state welding or some other laser welding or fusion welding, it is possible. But in the gas welding, and in this video, we are going to explain the gas welding and metal arc welding. The gas welding and the metal arc welding, compulsorily filler material is needed. So here design of welded joints will be advantages will be light in weight, stronger than riveting, involve less labor and time. Welding can be made automatic. Okay. Now here disadvantages already given due to uneven temperature, unwanted stresses may develop, need skilled labor, cracks may develop, and the inspection is very complicated. Because in other cases, then say the inspection of the riveted joints is so easy. Here the inspection process is somewhat complicated. So these are all the disadvantages of the welded joints. Then in the welding process, there's uses heat alone is fusion welding. So normally in the fusion welding, we are going to need the help of the filler material and other things only. But nowadays, today's scenario, fusion welding and the solid state welding also. The solid state welding, friction welding, then friction star welding, then other friction assisted welding. So many types are there. But here, the main concept is fusion welding. So fusion welding means it's the oldest type of welding only. But now the recent scenario, TIG welding, MIG welding, all those things comes under the classification of the fusion welding. So in this video, we are going to discuss about the fusion welding. Fusion welding, the parts to be joined are held in the position when the motor metal is supplied to the joint. Then in the fusion welding, that first step is the thermite welding, then gas welding, then electric arc welding. In the gas welding and electric arc welding, the what is the gas name is a mixture of oxygen acid the ratio, and here is the electric arc welding. Okay, so gas welding and electric arc welding comes under the classification of the what is called fusion welding. In the in the gas arc welding and the gas welding and the electric arc welding, compulsorily we need the help of the filler material. Okay, so that is the thing. And then welding, next the welding is combination of heat and pressure. So in the combination of heat and pressure, forge welding and electric resistance welding. In the forge welding, we have means of the proper furnace or forged and hammered. Electric resistance welding, it will be clamped together, and high amperage electric current is passed from one another. So this is the category of the electric resistance welding. This forge welding and electric resistance welding, they're used in special category or special purpose application. In that thing, we need the concept of the forge welding. Then types of joint, lap joint and fillet joint and butt joint. So lap joint is nothing but one joint over the other. There's a overlapping concept. Butt joint is two joints are joined simultaneously adjacent to each other. So here in the lap joint, single transverse fillet weld and the double transverse. See the picture carefully. So it's a single side. One side is welded. Here two side is welded. So single transverse and double transverse. Here double parallel fillet weld. So on two sides, because the main difference is the welding direction is parallel perpendicular to the direction of load applied. In the case of transverse weld, here the welding direction is parallel to the direction of the load applied. So this is the difference between transverse and the parallel. So two cases we were seen there. So single transverse, double transverse, and double parallel fillet weld. Okay. Next case is butt joint, square butt joint, single V butt joint, the W butt joint, single U and W. These are the various kinds of the butt joint. Then other types of joints, T joint, corner joint, edge joints. These are all the specialized. These are all the specific type of application is needed for the specific application. Now the transverse fillet is here we're going to see the derivation is. See the first picture. This is the side of the weld, this thickness. And here you drawn one perpendicular line, there's a reinforcement. So sine 45 means this distance. So the length of each side is known as leg or size of the weld. And the difference BD is known as throat thickness. So this is the throat thickness you have to measure in the diagonal direction. That is a BD. Okay. So throat thickness T equal to S into sine 45. This angle is 45. So S is sine 45, sine 45.707. So there is a value here. So now the minimum area of the weld area or the throat area, the formula is throat thickness into length of the weld, that is T into L, 0.707 S into L. So this is the formula we derived there. So this is for the transverse fillet weld, because in the next slide we are going to see the concept of the parallel fillet weld. So this is a transverse fillet weld. Okay. So the picture it is given single transverse, double transverse. Okay. So two things are the single transverse, double transverse. The next one is for the single transverse fillet weld, tensile strength, what is the formula? This is the formula P equal to A into sigma T. A is already defined, throat area into T, length of the weld. So T is the throat thickness, so W is the weld size. So P equal to 0.707 WL sigma T. Then for the double transverse fillet weld, here the tensile strength, the formula P equal to 2 into 0.707. Here why we are having 2 is it's a double side, two sides you have to multiply that. So 2 into 0.07 WLT. So this formula will be taken from the PSC data book. After finding the calculated value, then again going for the standardization value here. So the standardization value can be taken from the PSC design data book. So single transverse, double transverse. Here you note another one main difference. The transverse felt sigma T into will be taken into account, sigma tensile strength. In the parallel fillet weld, I will tell. So carefully note sigma T. Either here in the parallel fillet weld, two sides are parallel to the direction of the weld. Okay, tensile strength equal to 0.7 W into tau. Here two sides are the one side, two side. So this formula for weld stress are available in the PH 1.3. So here we are having the possibility of tau shear stress. In the previous case, single transverse sigma T, and here you can go to the value for the shear tau shear stress. In the third case, in the previous case, we discussed about the strength of the transverse and strength of the parallel weld. Here, the combination of transverse and parallel weld. So, strength of joint equal to P transverse P parallel. So, here 0.707 WL into sigma T. Why we are having two is this is single side L1 transverse. Here, one side is parallel, side 1 and side 2. So, 2 into 0.707 into WL into tau. So, this value should be taken from the PhD designated textbook. So in the problem, majority of the problems are having the combination of transverse and double parallel fillet weld. First problem, a plate 100 mm wide and 10 mm thick is to be welded to another plate by means of double parallel weld. The plates are subject to a static load of 80 kilonewton. Find the length of the weld if the permissible shear stress in the weld does not exceed 45 megapascal. Width is given, thickness is given, load is given. So first step, let L equal to length of the weld and W equal to size of the weld will be equal to plate thickness. Maximum load formula P equal to 2 into 0.707 WL into tau. Okay, so it's a parallel fillet weld. So we are having the concept of tau shear stress. So substitute the value here. L equal to 103 mm. So this is the load value. This is 2 into 0.07 1.14 W into L into tau. Now we are having the concept of 12.5 mm for start and stopping, because when we're going to overlap the plates, we cannot start the weld from the starting place. We got made some initial clearance on the top and the bottom side. So adding 12.5 mm for starting and stopping of weld. Okay, so this is a compulsory we got note from our side only, because without stopping we can't able to decide. So because we will we will start the weld from this portion means we are giving some gap. So some gap, initial gap we have to make as a clearance. At the end also, before going to stop the operation, we got to make some 12.5 mm gap. So adding 12.5 mm for starting and stopping the weld. So the original thing is L equal to 103 mm. So here L equal to 103 plus 12.5 mm, 11.5 mm. Okay, this is the thing. The simple problem. This problem comes under the classification of the double parallel fillet weld. So here the value was L equal to that value. Then L equal to 103 plus 12.5, 11.5 mm. This is the value here. Okay. Second problem is something different. So here plate 90 mm wide and 15 mm thick is welded to another plate by means of single transverse and double parallel fillet weld. Okay, this is single transverse. Here double parallel, parallel, double parallel. Find the length of the parallel fillet weld if the plate is loaded by a static tensile load. Take the allowable tensile stress of the plate as 70 and the weld shear as 50 so plate width on the 90, thickness equal to 50, sigma equal to 70, and tau equal to 70 because two strengths are given. Why it is given as here transverse is also there and double parallel flat is also there. So sigma t and tau will be given into account. So here maximum load is L1 equal to H into sigma t. This is for transverse direction. Then the design of welded joints is a combination of transverse and parallel fillet weld. Strength of joint equal to P transverse plus P parallel. So pi 1 into sigma T plus 2 into 0.707 WL into tau. Okay. So here sigma T corresponds to transverse stress and tau stands for shear stress. Then apply the values here. Then find the value as L2. Okay. By putting all the value because L1 is taken as the side of the joint, L1 equal to width of the thickness of the plate. So this thickness, this will be the considered as the thickness of the plate. So here you can substitute the values. You can find the L2. So L2 is unknown. This is the length of the parallel fillet weld. So here also one problem is given. It's a tutorial problem only. So this is a means of single transverse and double parallel fillet weld. The joint is subjected to a single transverse and the double parallel fillet weld. The joint is subjected to tensile force. The permissible and shear stresses value was given as 70 and 50. So determine the required length. So this problem is also total problem given the side. So same combination. It is a combination of the single transverse and double parallel fillet weld. So this thing you have to practice this thing. Now the strength of butt joints. So butt joints here two cases are the single V butt joint, double V butt joint. So it's a single joint is thickness of T and here T1 and T2. So the upper top thickness will be T1 and the down thickness will be T2. So single V butt joint and double V butt joint. The butt joint are designed for tension or compression. Consider single V butt joint. In butt joint, the length or leg or size of the weld is equal to the throat thickness, which is equal to the thickness of the plate. Okay, here what they are mentioning is the leg size. The leg size of the weld is equal to the throat thickness. In the first start of the slide, we derive one point. The leg size will be equal to the throat thickness, which is equal to the thickness of the plate. And then the tensile strength of the butt joint will be 2 cut a single V R square butt joint. So P equals strength equal to T into thickness into L into sigma T, where L equal to length of the weld is generally equal to the width of the plate because the weld up to the end of the plate only we can weld. So it is both are equal. So where L equal to length of the weld, it is generally equal to the width of the plate. This is for single butt joint or single V square butt joint. So tensile strength for W butt joint is shown in the figure P equal to T1 plus T2. W means top thickness and the bottom thickness you got to add in the previous and the diagram I explained. T1 is the top thickness and T2 is the bottom thickness. So T1 plus T2 into L into sigma T, where sigma T is the tensile stress. T1 equal to throat thickness at the top and T2 equal to throat thickness at the bottom. So it may be noted that the size of the well should be equal to the more than the thickness of the plate. Okay. So this is the case we have to explain there only. So mainly in the case of problem solving, single transverse and double parallel fillet weld, and in some cases we are going to explain by the concept of combination of transverse and parallel fillet weld. So this is the first part. First part only explained is the video. Remaining part is the main part, that is the eccentrically loaded welded joints. Okay, so eccentric loaded means the load is not acting at the center. These are all the loads are acting at the center of the joint only. In some cases, the load is not acting at the center only. So at that case, we are going to solve the problem by the concept of the eccentric loaded joints only. So that is the thing you have to know very clear only. So in this case, we are very explain about the tensation of the butt joint and tensation W butt joint. Similarly, we can use for the other kinds of joint also. So here also one recommended minimum size of weld will be there only. So here thickness of the plate is given because some data, because if your calculated thickness is not a standard one, it will be assumed as a equal one only. So thickness of the plate 3 to 5 one range is there, and 6 to 8 one is there, 10 to 16 is one there, and 18 24 1 is there. So depending upon the value, and over 58 thickness, you're having the minimum size will be 20 So these are all the things of recorded for the minimum size of the weld. So if your calculated thickness is not a standard one, you have to make it as a standard one. Okay. So you got to make it as a standard one, and you got to go in this slide only. So these are all the recommended thickness of the plate and the minimum size of the weld in only. So at last is the last thank you slide. So in this thing, design of welded joints purely this video explain about the basic types and basic concepts and small problems also. So mainly I'm focusing in the case of the what is the case, normal welding or simply parallel welding, or simply normal means center of the joints. Okay, axially loaded joints only. The next video I will clearly explain about the eccentric loaded welded joints. So the eccentric loaded weld joints, some different categories are there, different combinations are there. So everything that will I will explain the clear in the next subsequent videos. Okay. So thank you for your understanding. Once again, thank you guys. Um, the remaining topics of mechanical engineering design, I will explain in the next coming videos. Thank you. Thanks a lot.